Hey everybody, welcome back to the channel. Today's project's kind of overdue. I've got this tailstock I've been using for an awfully long time and probably abused it more than once. Anyways, it's in need of some love, and so today we're going to fix this up. You can see the end here is worn down pretty bad, and the fear is that this won't properly support a center hole if it's the wrong size center hole and lands in the wrong place on all these ridges and so on. And so I'm going to fix this up today, but I'm not just going to fix it as is. I'm going to upgrade it. I'm going to make the tip of it carbide so it's much more durable. I've got a small dead carbide end mill here, and I'm going to knock a chunk off the shank, and that's what we're going to use for our new tip on our center. I've got my setup made here already for this. I've got my spindle running true to the table and at center height. I've got my motorized workhead running true to the table, and I've got my diamond wheel dialed in on here. I've also got it running very slowly, as we typically do. The first thing I'm going to do is take a pass off the end of this and make it nice and flat, and then I'm going to cut this little blank to length. Now for what I'm doing today, I do not want a little nub left on there. I want that to be pretty much perfectly flat. So I'm going to go a little past center, and that ought to do it. I've disassembled my tailstock center here, got it out, and now I'm going to put it in my motorized workhead and blast the end of this off and put a nice flat on there. Just changing pulleys out here to get the speed running up to the 3450 RPM that the motor runs, because that's what this aluminum oxide wheel is going to want to run at. I'm all set up for the next process here. I've got my tailstock center in my motorized workhead. I've swapped my diamond wheel out for an aluminum oxide wheel, and of course I've sped that up. Now I plan on blasting this back till I have a 1/4 inch diameter flat on there. Now when I solder this little nub on, I won't be able to align it exactly, but that's okay. I figure by the time I grind this down to compensate for that misalignment, I may have gotten rid of a bunch of this stuff here, which is not critical to this working, but I wouldn't mind just having this fresh and dried up. We'll see how that goes. Yep, that's what I wanted. I'm going to be wanting to silver solder these together, so the next step I'm going to do is sandblast the areas where the soldering is going to happen, get them fresh and dried up. My plan here is to start by pre-tinning at least the carbide nub, and then soldering the two together later. Decided I'm going to pre-tin both pieces. That way I can inspect the bond on each individual piece. Then when I join them together, I'll know that I've got a really good bond. So hopefully you can see from there, but I'm super happy. I've got a real good complete bond on both pieces, and now I'm ready to put them together. I'm just adding some more flux to both of these. You can pretty much never overdo the flux. kind of got that a little bit soldered onto my pliers, so I'm going to try and snap that off. There we go. If I could give one piece of soldering advice, don't let any of it fall in your lap.
Good advice.
Yep. This is cooled down now, and I'm happy with the solder job. It looks like we've got a real good bond all the way around, I believe. And so we're going to move on to the next step. The next step here is to set my angle. This is a included angle of 60 degrees, so 30 degrees per side. Now, I am dialed now with my workhead, and if you look at my zero on my graduations, I'm awfully darn close to zero, but I'm not perfectly on zero. And I'm not going to trust this. I'm going to use my dial indicator to measure this angle in at 60 degrees. There's two steps really to setting up an angle using your equipment and not using the graduations, but using a dial. And the first thing I've done is set my dial up here, and I was very careful by eye to get it as true this way and this way as I possibly could. And then I've got some stops set here on my table. And if you look, when I travel from one stop where I'm at zero, go to the other stop, and I'm also at zero. So now I'm certain that my table's traveling exactly 1 inch. Now with a little quick trigonometry, we're going to figure out how much a dial on the indicating surface of my workhead should travel during that 1 inch of travel of the table. I've got my trigonometry all done. Now this little strip along the edge of my motorized workhead is it's a machine surface, and it's perfectly true to the spindle. So I've started by putting my graduations at the 30 degrees, but of course I don't trust that because it's not going to be exact. So what I've done is I've got my dial by eye as close to perfectly horizontal as I could, and as close as I could to perfectly square to the table. And I'm at one stop now. My dial's set at the zero. We're going to travel to the other stop, which is 1 inch away, and this should show us 0.577 inches of travel. It didn't. Here, wait. And that's awfully darn close, within a half a thou. So I'm going to call that good, and I'm going to move on to the next part of this setup. Basically, I'm going to take my aluminum oxide wheel off. I'm going to put a diamond wheel back on here, a plain style diamond wheel, and I'm going to slow up the RPM of my spindle back down. I'm all set now to start roughing this carbide nub down to the 60-degree point. See that little carbide nub? It's running out some as I expected it would, which is fine because by the time that's all cleaned up, I expect to be able to get a lot of the other damage out of the point on this. I'm going to continuously work this back and forth across the face of this wheel because I'd like to keep the face of this wheel as flat as possible. I'm not sure how this is showing up on camera, but there's some little shiny spots developing on the wheel, and what that is, it's the silver solder plugging the wheel up, and that's not going to help the wheel out any. So what I've got is a little stick here of aluminum oxide. It's a really fine grit, and by just rubbing that on the wheel, that's going to clear any deposits out of the wheel, freshen it right up, and let it cut freely again. I do make a point, a very careful point, of grinding very least amount of steel that I possibly can with a diamond wheel. It really wears them down quickly, so it's expensive. But in this case, I'm wanting to clean this whole thing up at the same time, and so I kind of have no choice, and I'm just being very frugal with how much steel I'm actually grinding. I'm pretty much the size here, but I'm not at all happy with the surface finish. What I don't want is this carbide having such a bad finish that it's abrasive and wearing away at my center holes in tools, because you never want to wear out a center hole in a tool. So I'm going to strive for a better finish. Now, I've said this over and over and over again, that you have to run diamond wheels very slowly, and that's for grinding carbide, and that gives you maximum life of your wheel. But I'm going to try two different things to improve this finish. One is I'm going to speed this wheel up to the full 3450 RPM that the motor runs, and I'm just going to touch it, and I'm going to see what that does to my finish. If I'm not immediately happy with that, I'm going to switch to a different wheel, and we'll see how this works, and then we'll talk about the next thing if this doesn't work. Well, let's see what happens here. Now, I've never actually tried this before with the diamond wheels, but it's a well-known fact that in grinding in general, faster gives a much finer surface finish. So we're going to see if that holds true in this case. This surface is way better, but I'm still not crazy happy with it, so I'm going to try plan B and see what that does for us. We've done all this work so far with this 100 grit diamond wheel, which is pretty aggressive in the world of diamonds. I'm going to switch my setup around now, and that'll allow me to use this 320 grit, much finer diamond wheel, and we'll see if we can improve that finish any. So I've had to reconfigure things quite a bit here. We were using a plain style wheel before. I don't have a finer wheel in a plain style, so I've gone to a dish style wheel. So a bunch of changes, but as far as the setup with our center goes, that remains the same. I am leaving it spinning ridiculously fast, again with the hopes of getting a better surface finish. So let's see what happens. I'm super happy with that finish now. It took a bunch of playing around. The diamond spinning faster than it should seemed to really work. When I started out, I had the motorized workhead spinning as fast as it would go, and quite often that's what gives the best results, but it really wasn't here. I ended up slowing the motorized workhead down to as slow as I could get it to go, and really feeding incredibly slowly out with the table across the surface of this wheel that was doing the cutting, and that's what gave us the results I was looking for. There we are, all back together. I'm super happy with that. This carbide tip on this tailstock is going to last an awfully long time. I got over 30 years out of this with tool steel tip on there, so this might be the last tip I have to put on here. If you're enjoying these videos and you'd like to help support the channel, consider joining us over at Lappy Mountain Living at patreon.com. I'm looking forward to it. I think we're going to have some great conversations, and we're going to do a lot of other fun stuff over there. Well, that's going to do it for this video, guys. Thanks for watching. We really appreciate it. We'll see you in the next one.